Welcome to section 4.8. Our objectives are I can prove the theorems and apply properties about isosceles and equilateral triangles. This lesson should be fairly easy because we already know a lot about isosceles and equilateral triangles. Just remember, isosceles triangles are like that ice cream cone where two sides are congruent, and equilateral triangles are the triangles where all the sides are congruent. So on this, the congruent sides are called the legs of the triangle, and the vertex angle is the angle formed by the legs, so these. Okay, so we think of those as usually base angles. So just think of where like the ice cream goes. There's the ice cream. Cherry on top, yay. So where the ice cream goes, those are going to be your base angles, and then your legs are the equal parts. So on an isosceles triangle, our isosceles triangle theorem tells us that those base angles are congruent. So if we have an isosceles triangle, the base angles are congruent. So if we have an isosceles triangle and this was 50, then we could also say that this is 50 degrees. Now the converse tells us the other way. So if the converse tells us that if we have a triangle and the two base angles are congruent, so if we got 20 degrees and 20 degrees, we can say, well, this is isosceles. These are congruent. So if we have these base angles the same, and maybe that's 5, we can conclude that this is also 5. So the original is sides are congruent, therefore angles are congruent. The converse is angles are congruent, therefore sides are congruent. And if you get lost, you can look in your book, just the conclusion. We're concluding that the angles are congruent here. We're concluding that the sides are congruent here. Okay, so look at this one. The length of yx is 20 feet. Cool. Okay, so we have 20 feet here. Explain why the length of this is the same. Well, we have 140 degrees here, and it looks like we have an exterior angle. If you guys remember exterior angles theorem, we have a 40 here, which means that this must be 100. Because this one plus this one equals this exterior angle, and hopefully you guys remember that. And then to find our final angle here, we know the whole triangle is 180, or you could use a linear pair here, and you should get 40 here. Now, since these two angles are the same, they're both 40, by the converse of the isosceles triangle theorem, we can conclude that this side is also 20 feet, and you can write that all out. This is how they wrote it, but I just talked about it. There you go. Okay, so let's find angle F in this particular case. So looking at this, we have the sides are congruent, which means that these angles are going to be congruent. Now this whole triangle is 180, so I can subtract the 22, and we get 158. Yeah. And then we could divide that evenly between the two, and we get 79 each. And if you did it right, all of these should add up to 180 again. So you can double check that way too. Okay, find angle G. So I know that these are the base angles because I see that we've got congruent there, congruent there. My ice cream would go over here. So I can set them equal to each other, and I can solve for x. Now after I solve for x, I can plug it back in to find G. You're going to plug it back in right here. So 22 plus 44 is 66 degrees. Okay, so recap, if I have congruent sides, the base angles are going to be congruent, and if you need to turn your book or page or whatever to see where those are, you can do that. And then set them equal to find x, plug x back in, and you got it. Okay, find angle H. So this is the same as the first one we did. The whole thing is 180. We could subtract the 48. They did it a weird equation way, but that's okay. Okay, and then we get 132. And then we could divide that by 2, and we get 66, and this is my x, which is my angles. 66, 66. And this whole thing should equal 180 again. Okay, angle N here is what we're trying to find. I see my base angles are here and here, which they're congruent. Set them equal to each other. solve for y, I get 8, and then I plug 8 back in to whatever I'm trying to find, angle n. So I'm going to plug 8 back in right there, and I get 48 degrees. It's all about equations. Okay, equilateral triangles, a lot easier. All the sides are congruent, and all the angles are also congruent. So if it's equilateral, it's also equiangular, if you remember that. All the sides are congruent, so all the angles are congruent. And an equiangular triangle, all the angles are 60 degrees. And if you forget that, just remember the whole triangle is 180, divide that by 3, and you get 60. Okay, and if you have an equiangular, then it's equilateral. It's just kind of a given. That's what corollary means. So this is equilateral. It's telling us that. Okay, so I know that all these sides are going, or all the angles are going to be congruent as well. Now, instead of setting this equal to itself, that's not going to do anything. I know that this angle is going to equal 60 degrees. So if I'm trying to find x, I can do 2x plus 32, and it's going to equal 60 degrees. And now I can solve. So subtracting 32, I get 28, and I get x equals 14. Okay, so never try to set it equal to itself if it's the same number. You're not going to get anywhere because it's going to cancel everything out. So just make sure you set it equal to something that you know, which is 60 degrees. Okay, find the value of y. So this time we know that the sides are congruent. I see that these are different values, so I can set these equal to each other. Okay, subtract 4y from both sides, add 6, y equals 18. Okay, JL, same thing. These sides are going to be congruent because all the sides are congruent. So set this equal to the other side. And then you get 4.5, which I'm looking at this, I think I was supposed to find, nope, just y, okay. And then you're going to plug it back in to find JL, so 2 times 4.5 plus 1, I get 10. So make sure you double check what you're trying to look for. If you're looking for the variable, you can stop there. If you're looking for the actual side length, you need to plug it back in. Okay, so here we have a coordinate proof, and I'm just going to show you the overview of it. We're not going to go through it in super detail, but given this triangle, an isosceles ABC triangle, x is the midpoint of AB, and y is the midpoint of AC. So when you're graphing this, you're going to have to do a little bit of math with the midpoint. Okay, and actually, since they don't tell us where this is, so you can just kind of graph it wherever you want. And we're going to prove that xy is half of AC. So my if-then statement's a little weird. You don't need to say all this. You can just say if xy is half of AC, then xy is half of AC, which is weird to say that. It's kind of repeating itself. I do believe there's one of those on your homework, but it's okay to say that. So if this happens, then it happens. If xy is half of AC, then xy is half of AC. Okay, and so we graphed it. We have 4a here, we have 2a, 2b, that's a little weird. If you want to use actual points, make up some points, it's perfectly fine. So if you want to say that this is like 2, 2, and this is like 4, 0, that's fine, go for it. Okay, and then you're going to use the midpoint formula to plot x and y, and then you'll use the distance formula to show that AC is half of xy, so you'll find the distance of xy and the distance of AC. Okay, and I'm not going to do that last one, but there you go. That's that.